Welcome to my pre-algebra class. We're on chapter 10, section 11, and we're going to be working with the Pythagorean theorem. The Pythagorean theorem, discovered by the gentleman named Pythagoras, involves a right triangle. So remember, a right triangle has one right angle. And the two sides that make the right angle are called legs. So this is leg A and leg B. And the side across from the right angle is called the hypotenuse. And we call this side C. And the theorem is this, that if I square the legs, a squared plus b squared, it'll equal the hypotenuse c squared. And this gentleman figured that out. And we use that quite a bit, and it also developed the mathematics called trigonometry. So we're going to use that to find missing sides. So here I have a right triangle, and I want this side here. So I'm going to use my theorem. I'm going to write it down each time so I remember it. A squared plus b squared equals c squared. This leg, I can let that be a squared. B squared is going to be 9 squared, and it'll equal c squared, which is going to eventually be x. So I come out with 36 plus 81 equals c squared. Add that together, I get 117 equals c squared. So c would be what number times itself makes 117, so that would be the square root of 117. And if we round to, I think they round to the nearest tenth on most of these. Yes. So the answer would be 10.8 because the 1 will keep it 8. So our answer is 10.8. And that's our missing side. In the second example here, I have one leg missing, one given, and the hypotenuse. So I'm going to use my formula again. A squared plus b squared equals c squared. This time I'm just going to let a squared be the side that I'm missing. B squared is 48 squared, and c squared, the hypotenuse, which is given, is 50 squared. So if I don't know my perfect squares, I'm going to go 48 and just hit the square key. First we need to clear it. 48 squared is 2,304. And 50 squared is 2,500. So I solve my equation for a squared. Subtract 2,300 from both, 2,304 from both sides. I get 196. A squared equals 196. Now I want what number times itself makes 196, so I take the square root. And a equals, and I believe 196 is a perfect square. It is, it's 14. So our missing leg is 14. So that's how we're going to use the theorem to find missing sides. And the last part of your assignment is going to be asking you if a triangle is actually a right triangle, and we can use the theorem to decide that. If I always let the longest side be the hypotenuse, which is true of a right triangle, and the other two sides be legs, I can apply the theorem and see if it works, if a squared plus b squared does equal c squared. So I'm going to test this. 12 squared is 144. 16 squared is 256. And 20 squared is 400. And if I add 144 and 256, I get 400. So the sum of the legs squared does equal the hypotenuse squared, so yes, it is a right triangle. And that's what we're going to use to do our problems. So you need to get your book open to page 483. We're doing 1 through 20. Have your calculators handy. And the directions on 483, find the unknown length, if necessary, round to the nearest tenth. Use a calculator. Okay, so number 2, we have a right triangle. We have the legs given. and the hypotenuse is missing. So a squared plus b squared equals c squared. So we can let 18 be a and 24 be b, and we're looking for the hypotenuse. So 18 squared is 324, and 24 squared is 576. We add those together, we get 900 equals c squared. Take the square root of both sides, and we get c equals 30. So our hypotenuse was 30. Number 4, we have a right triangle. We have the hypotenuse given, but b is missing. So a squared plus b squared equals c squared. A squared, 8 squared, plus b squared is missing, equals 13 squared. A squared is 64, and 13 squared is 169. You can check that on your calculator. So to solve for b squared, we have to subtract 64 from both sides, and we get b squared equals 105. So b has to be the square root of 105. So we take 105 and take the square root, and to the nearest tenth, it's going to be 10.2. So b equals 10.2. Problem number 6, the hypotenuse is given again, but this time a is missing. A squared plus b squared equals 20c squared. So a squared, one leg's missing. B is given, it's 24. We're going to square that, and it'll equal the hypotenuse squared, 26. So a squared plus 24 squared is 576. And 26 squared is 676. Subtracting 576 to solve for a squared, we get a squared equals 100, and the number times itself that makes 100, the square root of 100 is 10. Problem number 8. Is the triangle with the sides given a right triangle, right, yes or no? So we're going to use the theorem and check it out. So write the theorem down. And for number 8, it's 8. Always make sure that the longest side is the hypotenuse. So 8 squared is 64, 10 squared is 100, and 12 squared is 144. 64 plus 100 is 164, and it does not equal 144, so no, it's not a right triangle. Problem number 10, formula is a squared plus b squared equals c squared, and 9 squared plus 12 squared would have to equal 14 squared. 9 squared is 81, 12 squared is 144, and 14 squared is 196. And if I add these together, I get 225 equals 196. It does not, so no, that's not a right triangle. And number 12, I'll make sure the longest side is the hypotenuse, so 15 squared plus 20 squared has to equal 25 squared. 25 is the longest side. 15 squared is 225. 20 squared is 400. And 25 squared is 625. If I add 225 and 400, I get 625, and it does equal 625. So yes, that is a right triangle. And the last part are some word problems where we're going to use the Pythagorean theorem. Often the Pythagorean theorem is used as a method of indirect measurement. In the following figures, use the theorem to find the unknown distance. If necessary, round to the nearest tenth. So number 14, we have a right triangle. The hidden lake The distance across of it is the hypotenuse. So we're going to use a squared plus b squared equals c squared. So we have the two legs given. 32 squared plus 24 squared has to equal c squared. 32 squared is 1024. And 24 squared is 576. Adding those together, we get 1600 equals c squared. So we want to take the square root, find out what number times itself makes 1600, and it would be 40. So the distance across that lake is 40 meters. 16, we want to find the height of that pattern inside that diamond, and we can see that that's a right triangle, this part of it right here, and it's 4, 4, here's the right angle. So our hypotenuse is what we're looking for. And the sides are 4 each, so 4 squared plus 4 squared has to equal c squared. That's 16 plus 16 has to equal c squared. If we add that, we get 32 equals c squared, and we're going to take the square root, and since that's not a perfect square, we're going to round it to the nearest tenth. Since the 5 is greater than or equal to 5, we're going to make it 5.7. So the height of that inside that diamond is 5.7 inches. Problem number 18, it says a ladder that is 6 meters long leans against a wall. So its ladder is 16 meters long. The bottom of the ladder rests 2 meters from the base of the wall. How far up the wall does the ladder go? So we're looking for a side of a right triangle. So we have a squared plus b squared equals c squared, and we do have the hypotenuse in one leg given. So a squared plus 2 squared equals 16 squared. A squared plus 4 equals 16 squared is 256. Subtract 4, and we get a squared equals 252. Take the square root of both sides, and the 252 to the nearest tenth, 7 is going to make it go to 9, so it'd be 15.9. I goofed here. Just leave this as 16. I know it's actually in the book it was 6. But let's make a big long ladder. It's okay. So just leave it as 15.9. My mistake. I caught it, so no candy. And number 20, a square gate is reinforced by a wooden brace across its diagonal. So this is basically what you have. You have a square gate, and you have a diagonal. As a brace, the perimeter of the gate is 12. So if the perimeter equals 12, remember perimeter of a square is 4 times one side. So if I take 12 and divide it by 4, I find out that one side is 3. So this is 3, and this is 3, and I want the length of that gate, or the brace rather. So I can use my Pythagorean theorem. A squared plus b squared equals c squared. So 3 squared plus 3 squared equals c squared. That's 9 plus 9 equals c squared. Add that, I get 18 equals c squared. Take the square root of 18, and to the nearest tenth, the length of that brace is 4.2, since 4 is less than 5. That concludes the evens. Be sure you check the back of the book for the answers to the odds.